welcome to those who are joining. We're at, I see 53 participants. So we should get started here pretty quickly. You are joining the Reinvention Collaborative sponsored workshop on curricular analytics. I'm Stephen Dandino, the Executive Director of the RC and Associate Provost at Colorado State University, the host of the Reinvention Collaborative, and we welcome you all to this 2-hour workshop. I was looking through the list of registrants, and I did, one name jumped out at me. It was Hayden Free. It just says next to his name, student, University of Kentucky, and I know that to be a falsehood. He's a super student, is what it should say, and he will be co-presenting today alongside of Dr. Greg Heilman of the University of Arizona. I also was just looking at all the folks who are joining us today. It's an impressive group of university leaders in all 4 time zones, I might note, and regardless of your zone, we know your time is valuable, and we're appreciative of you making time for this meeting, and we also are, aware that it's Friday and that you're making time on that day as well. We're grateful to you all for doing that. Let me just go ahead and introduce Dr. Heilman and turn it over to him and Hayden, and what they're going to do is present curricular analytics in such a way that if you're new to the toolbox and this is your first introduction, you'll come away from today with a good appreciation for what it's all about. But also, I know many of the folks that are joining us today are familiar with curricular analytics, perhaps even have used it on their campuses to some good effect. And so for those folks, there'll be plenty of new information and new developments that are exciting, and you'll come away familiar with that as well. So Greg Heilman is the Associate Vice Provost for Academic Administration at the University of Arizona in Tucson. He's held university leadership roles previously at the University of Kentucky, where he met super student Free, and also at the University of New Mexico, which I think it's fair to say is the place where curricular analytics was originated between Greg and his colleagues there at UNM. He is professor of electrical and computer engineering, and his research has over the years generated some $9 million in external grants and funding, and he's the author of over 170 peer-reviewed publications in his field. As many of you know, Greg is a member of the Reinvention Collaborative Board, and we're grateful for his leadership and participation in our national consortium. What you don't know, perhaps, is that he was a former professional soccer player. Me, I probably, if I tried to run the length of a soccer field, I probably wouldn't make it. He can do it, and I think it's just an example of engineers. They're can-do folks. There's really nothing they can't do. If it's curricular analytics or it's soccer, they can do it. And so, Greg, without further ado, or additional embarrassing information about you, I'll just turn it over to you and Hayden, and thank you again so much.
Thank you for embarrassing me, Steve. I appreciate it.
No problem.
I do want to say that there's no better way to end a Friday. This is the best group of people that I've worked with in higher education, bar none. And it's been the most impactful group in my work over the last 7 or 8 years. So I really, really appreciate what the Reinvention Collaborative does, what they stand for, and the opportunities they've provided. I do see a number of folks on the call that I see Rick and David and of course Steve who've used this tool. So if at some point you want to interject, please feel free to interrupt at any point in time. We've probably got more material than we can cover, so I'll kind of give you an overview and we can jump to different portions of this. I'm going to send a set of slides out to Liz that she can pass along to all of you. At the end of this, I've got to do just a little bit of editing, and then I'll get those slides out to you so that you can have them and look at some of the studies that we maybe don't have time to go over. I see one person is actually at the Four Seasons, very impressed. And anyways, let me start by sharing the screen. Oh, and Sue, you asked a number of questions, And I hope that they're embedded in this. So if at some point, likewise, if you want to dig deeper on something, please feel free to interject. And that goes for everyone on this call. Okay, can everyone see this presentation? Okay, all right. Steve, you just interrupt if because I can't really see the comments at this point. So if we need to interrupt or we need to have a break, just feel free to speak up, please. So this is a talk on curricular analytics, and as Steve mentioned, is something we've been working on for the last 7 or 8 years, and it kind of has been growing in terms of capabilities and what we've been trying to provide. We've been trying to make tools widely available. I think the tool set we have right now is pretty powerful. What's out there for people to use, what's available through the website is a little bit behind what we can do in this toolbox, and we'll explain some of this to you in just a moment. I see someone. I just admitted someone. Okay. And so I'm going to come back to this puzzle in just a moment, but this is contact information for both myself and for Hayden. Hayden has been wonderful. He has been, I would say, most of the lines of code behind the toolbox, behind the website are his work. And there's another person, Trace Norris, who's put a lot of work into that website as well, working with Hayden and I to try and provide something that's usable to you. With that in mind, if there's some pieces of this web application when we start to show you how to use it that you don't think is user-friendly, please speak up. We gladly take input and try to fix things given free time that we have. For this workshop, what I'm hoping is that after sitting through this, you'll kind of understand the metrics and statistics that we have created that are related to both the complexity of curricula and something more recent that we've been working on is analytics related to degree plans as well. And I'm hoping that you'll be able to provide them maybe in your own campus scenarios, and I'll give you some examples of how we have used them. We're going to show you how to use the tools that we have. So we'll go through a pretty deep dive on kind of how to get in and create curricula and do analytics on those curricula. And I'll show you some studies where we incorporate analytics into curricular redesign efforts, as well as how kind of a look forward on how we now have tools where you can use the analytics to actually create customized degree plans that we think will be very important in advising practices. So how do you create a plan for someone who's coming to college with 30 credit hours, dual credit? How do you create a minor major combination very easily? How do you create a plan for someone who wants to double major? These are difficult things for advisors to do, but it's something that is computable, and it's something that we can make their lives a lot easier by providing tools to make that easier. Here's a quick agenda. So we're going to kind of go over the background of what we've done. I'll provide some terminology, talk a little bit about curricular analytics, then we'll go over the tools, and then time permitting, we'll get to one or more of these studies. We can cover however many of these studies you're interested in, but I have left them there, the slides there for you to go through if we don't have time to actually go into detail on any of them. So as a background, the etymology of the term curriculum, I think is kind of an interesting, and I see Steve laughing because I've used this in another talk, so he knows what's coming. But this was the term curriculum actually means the course of a race, and it was first used in a university context at the University of Paris, and in a posthumously published textbook by Petrus Ramus in 1576. And it's linked to this desire, this Calvinist desire to provide order. And Petrus Ramus was in the Catholic center then at the time, which was Paris. And this is what happened to him. And they say this is the Saint Bartholomew Day massacre, otherwise known as a faculty meeting, I believe. This is the other thing that could be interpreted. It could have been a faculty meeting where he brought up a curricular change. David, what do you think?
I agree. I'm just trying to figure out where I would be in that picture.
Yeah. Well, one of this up here is faculty, faculty only, and so providing tools where you can discuss curricular change using metrics is something that we found has made it much easier to move conversations along. And I know that Rick Miranda's on the call. He made that point very eloquently at an APLU meeting about how they've used these tools to spur just conversation that is inclusive of faculty rather than making them defensive. So I might let Rick speak to that if he wants to at some point. This is kind of what started it off for us. I had an undergraduate student. We were working on trying to provide a degree plan for the student. He said, it's like trying to put a puzzle together, but I can't see the picture. You're not letting me see the picture. And so that's the point of that puzzle picture that I showed you. And so we worked to create these degree plans. And so we've got now a web app that's not available on something we'll show you today. But if you're interested in this, it's a tool that we now have available, and it's being used at a number of places around the country where you can make your degree plans available online. So here is an accounting degree, and it gives you the semester by semester set of courses that you need to take. And if you click on this grid, it shows you, well, here are the courses in a grid finance. I need a business finance, then I can take those two courses shown in green. And so this was kind of a nice visualization, but another way to represent that is as a graph. So that last thing I showed you, it's the same thing as this graph where the arrows between, the circles are nodes and they are courses. And the arrows between those courses are prerequisites. And I'm hovering over the same course here, and it shows me, those arrows show me the prerequisites that I need to get into this finance class, and then what it opens up for me to take. And this led us to think about the fact that, guess what? These curricula are data. You can treat them as data that can be analyzed because they have a graph structure, and that graph has properties. And so the analytics that I'm going to show you involve analyzing this graph structure for the most part. So in order to get on the same page with this, I just wanted to point out a couple of the terms that we'll use. Because sometimes that can lead to confusion. So, we use the term academic program. This is the pedagogy organized around a specific discipline. So you might have an AS in chemistry, BA in music, BS in biology, right? Those are academic programs. These academic programs have a set of degree requirements that a student must satisfy. And if they do, they get the degree. Generally, those requirements are courses, and hence the graph that I showed you, right? You understand you pass courses, you earn credits. Credits get you closer to satisfying the degree requirements and earning the degree. So then a curriculum is a way of structuring those courses so that if you complete them, you satisfy all of those degree requirements and you get the credential, right? So in our web app that we're going to show you shortly, this is the notion of a curriculum. So I've got the New Mexico State University Microbiology BS program here, and you'll see it laid out as the graph that I showed you before. But here there's a curricular complexity number here, and we're going to talk about how we can come up with that metric shortly. The thing to notice here is that there's no notion of terms in this, right? A curriculum, there are no terms in a curriculum, right? In order to make a degree plan out of this, I've got to overlay a time element. There's no time in this. It's just this course requires this other course, right? So a degree plan, we add that temporal element, and now you have term by term arrangement, right? And so I can analyze that curriculum. And one thing to note is that no matter how you organize your degree plan, the metrics that we've created, it doesn't change the underlying curricular complexity. Now we can change complexity metrics associated with this degree. And this notion of, are there some degree plans that are better than others for certain students, is something that we're investigating. And in fact, I believe that's an important equity issue that Steve and the Reinvention Collaborative in general are looking at, is the equity, the structural equity that's built into curricula, that's built into degree plans. And, you know, it's interesting, in the provost talk yesterday, Bernard Mayer talked about the decolonizing of curricula. I think if you're going to go through these reviews of curricula, you might also look at these other structural inequities that can be in curricula. That's a content, decolonizing is a content focused thing. This is more of a, is it equitable to students from different backgrounds? So that's a really important question that we are very interested in answering as a part of this work. So I put this down here because it's actually, you know, if you think about it, right, you've got a set of degree requirements. How I pick courses, like there's so many different ways to satisfy Gen Ed core, for example, right? Each of those could lead to a different curriculum, right? If I say, you know, satisfy Gen Ed core in this way, right? So anytime there are course options, you can have a different curriculum that a student might follow. And for each curriculum, there are many different ways of organizing the courses in a curriculum. And if you think about it, it's actually far more than people realize. The job that an advisor has to do, if you do it, if you analyze it mathematically, the mapping from a curriculum to all of the degree plans you could create for that curriculum and finding the right one. So, and I'll have Rick check my math on this. I think I saw Bernard might maybe logged on too. We've got at least 2 mathematicians, but you take the total number of there's about 40 courses in a typical undergraduate curriculum. So there's 40 factorial ways of organizing them, right? Now divide that by the number of, it doesn't matter if you break them into 8 terms. So divide that by 8 times 5 factorial. And that's roughly the number of different degree plans you could create, and not taking into account prereqs. If you add prereqs, then it in astronomically large. And that's the space that is interesting. So I won't spend more time on that now, but just I do want this mapping from a curriculum to a degree plan for a student is a far more difficult problem than people realize, but it is a computable problem. So you can actually find optimal solutions to it. So the initial work that we did in curricular analytics looked at, you know, how does the complexity relate to student success? And one of the things we found at our early work at the University of New Mexico is as curricular complexity goes up, completion rates drop. And we found a correlation about 17 points in curricular complexity led to a 1-point decrease in graduation rates, 6-year graduation rates, right? How different, like if you look at your program in microbiology and compare it to, you know, the one in the next state, how similar or different are they? And it was actually remarkable how different our curricula are. And when you apply it to programs that have the same accreditation, you know, and ABET in the extreme, every program has to have the same learning outcomes. They're producing engineers with the same learning outcomes using vastly, vastly different curricula. Are some better than others is a question that we wanted to ask. And then can we use this to guide 2+2, you know, transfer articulation plans? Can we think about how we divide up the complexity of a curricula between the 2-year and the 4-year school in an equitable way? And this is some work that is going on at New Mexico State University, also at Virginia Tech. I've seen them looking at that. More recently, we've been looking at you know, these many different degree plans that can be created for a curriculum. Are there some that are better than others? A slight edge, can you get a slight edge? You know, a student who gets a 1.9 GPA in the first term is on academic probation and may lose scholarship. A 2.1, completely different story. That student who earned the 1.9 is likely leaving, right? 2.1, more likely to be staying. And so can that tiny change in how you structure someone's plan make enough of a difference to change retention? This is something that's, I think, a very interesting question. Again, something that we're looking at. This combination of curricula and more recently, this is actually with Carol Parker at NMSU and Ad Astra, we're looking at if we can get students on these personalized plans that are more accurately reflective of what they're going to do, maybe we can save some money by sections of a class, better predicting our course rates and better serving students through the are interested. So how has curricular analytics been used, right? So far, we've seen it used in curriculum redesign. This is by far the most common use. The APLU folks, the Western cluster used it. So can you compare and contrast curricula at different places? Can you just look at the complexity of your curriculum and identify outliers? So this is this ability to compare. What the APLU Western cluster schools did, they put all their curricula, they created an inventory of their curricula. Once you have that inventory, there's kind of some interesting things you can do. You can start to look at combinations of majors and finding courses that are in a lot of majors that are going to have the largest impact if you might change them. And you could actually start to estimate the impact because you can see how they impact the entire curriculum. So this is this notion of maybe looking at meta majors, important courses, or complexity outliers in your inventory. You can compare and contrast a particular program. That's the other thing that we looked at is let's look at animal science across all of the Western cluster schools. Why are some not complex and others are highly complex? They may be a good reason for that, but it's good to get people in the discipline thinking about that. Also something that we're seeing people do across the state system. Academic program review is another place where you can use program review. You have to compare your program to 20 peers and looking at how they offer programs and versus how you offer that same program can be very helpful. It also relates to student success metrics, right? You can look at change of major, how are transfer students and other success types of metrics impacted by having a curriculum of a given complexity. More recently, we're creating a software engineering program here at the University of Arizona. And we use this to collect all of the software engineering programs that we could find out there. And I have a workbook and I'd be happy to share this with you, but this was a really innovative, I think, way of, if you're involved in new program creation, one of the things that the university is going to ask of you is how many students do you think you're going to get and what are the resources you think you're going to need? Well, we use this to estimate that. We looked at all of the programs that were out there. We looked at their enrollments, and then we just did a regression. We found that software engineering enrollments are highly correlated with computer science. So if they have a computer science program at the same, then we could pretty much predict what our enrollment's going to be. And then we were able to map out a curriculum that we're able to create a curriculum and map it out and use that to estimate how many new courses we were going to need to offer in order to provide this degree. And from that, we were able to estimate how many new faculty we would need. So, given that we were able to get an estimated number of students, this is what the curriculum is going to look like. This is the number of new courses and so forth. So it was kind of a nice way of visualizing all of that. And then, excuse me, let me get this, there we go. Transfer articulation is something that we've been working on more recently, right? How efficient can we make that process? Is it equally balanced? Again, I mentioned NMSU is looking at this. We've created a statewide system in the state of Kentucky, working with the Council on Post-Secondary Education. We are in the process of creating a statewide transfer articulation system. We'll talk about that a little bit more. And then finally, this notion of personalized degree plans. I put asterisks by these two because there's new capabilities in our toolbox that require optimization, and they're pretty sophisticated optimization techniques that required us to purchase a commercial solver. So we can't make that one available because it would violate the license. So we're trying to figure out how to make this available so that we can cover the cost of that commercial license so that we can solve these optimization problems and make this available to you. So we're working on integrating that into the website. So these last two things, they're not currently available in the web app that we show you, but we're trying to figure out a way to make them available to you. So quickly, the tools that we have, we've got the web application that Hayden's going to take you through in just a moment. Allows you to compute structural complexity, different degree plans. If you use the old version, and I'm wondering if, I don't know if we could do a show of hands, what's the right way to do this, but how many people use the old version of our website? Okay, I see some hands. Steve, you're adding them up?
People have their camera off.
Okay, so here's the deal. The old version of that website, everything was kind of done within the JavaScript associated with the web app. And if you uploaded a curricula, everyone could see it. And it was a flat structure. You had your curricula and there was no way to organize it in any type of a hierarchy. We changed that in this new version. So now if you are working at the provost office level, you can create a university level account for yourself, an organization. And then you could, under that, create an organization for each of your college, and the college can create organizations for the departments, and you can collect all of these for an entire institution. So that's one of the things that we've now done. And so you can much better organize your curricula. Hayden will spend a little bit more time discussing that. And you can get a measure of structural complexity. And the other thing you could do is, the only thing that you could upload before was just a degree plan. Now you can upload a curriculum, and you can upload a different degree plan, as many different degree plans as you'd like. So you could create one for each student at your school if you wanted to. So that's the other thing now, is that this notion of a curriculum can have many degree plans is now embedded in this new web app. We're working to make this web app more and more user-friendly. So that's I would say the thing that we're working on now is just to try and make it easier for you to use. The other thing is this Curricular Analytics Toolbox, which is the engine now that does all the computation of curricular complexity, that now is running behind the toolbox. It does the computations and returns the results. That wasn't being done before. This will allow us to provide much more sophisticated analytics going forward. If it's in this toolbox, we can put it into the web app at some point. And so over time, we're going to add more and more and more sophistication to this web application. You can do quite a few sophisticated things through this toolbox, but it requires you to program. So if you have institutional research folks who are interested in that, we're happy to work with them. And in fact, Hayden and I do routinely work with, in fact, we had a call with South Florida earlier this week where we work with their IR folks and we show them how to run these tools. So if you have IR folks that are interested in this, we can try and help you on that front. And then we've created a notebook site where we're trying to share our research. So if we do a study, we're trying to put it up there so that you can recreate that study with your own data if you'd like. And so these two kind of require you to program. So as I mentioned, if you go to www.curricularanalytics.org, then this is where the web application is. And we're going to spend some time on that site right now. So this is where you can upload a curricula and you can associate degree plans with that. Hayden just got a really nice new feature working. You used to have to create CSV files. You used to have to create basically a spreadsheet for your data. Now you can do it graphically. you can build a curriculum entirely from a user interface right now, if you like that. So he's going to demonstrate that to you. I think he got it working maybe this week. And so I want to really quick tell you what you're going to see on this website. So the way that we have cast the complexity of a curriculum is two components that we believe are independent. How you teach, which is the instructional complexity, right? The inherent difficulty of the courses, the quality of the faculty, the student support you provide, and then how you structure the curriculum. So you can change how you structure your curriculum without changing those instructional modalities or how you teach, and vice versa. You can not change the structure and find a course that you really think you need to improve upon, and provide all sorts of supports for that course and perhaps get better outcomes for that course. We have a new capability in the Toolbox. It does require you to program, but you can now simulate. We have a simulation capability where you can take a collection of students, 1,000 students, and run them through a curriculum and say, I'm going to improve my pass rate for this course by 5%. And I'm going to see the impact that it has on student success. And I'm going to do that, you could do that over a collection of programs. Right? If you improve the pass rate in Calc 1 nationally, we would produce a lot more degrees. I can tell you that right now. Well, we can simulate that now. And we could also simulate what would happen if we reorganize the curriculum in a particular way. Many of you have probably served on curriculum committees, and you make a curricular change and it takes about 6 years to see what it did to the 6-year graduation rate. What we're trying to do is provide the ability to estimate that through simulation. So make some rational assumptions and then let's simulate that. So we're trying to provide tools to actually estimate the benefit that you might get for particular changes. So the structural complexity is what you're going to see in the web app. It doesn't touch on instructional complexity. But again, the important point is we believe these are independent. We believe you can look at one without having to touch the other. So these are the kind of 4 things that we think impact the structural complexity of a curriculum. And it's what you're going to see when you upload a curriculum into this website that you're going to see in just a moment. And we can go back over this again if some of this isn't clear to you on first pass through this, we'll come back to this. So the delay factor are long pathways in a curriculum. We call that a delay factor, right? So in some curricula, you have Calc 1, followed by Calc 2, followed by Calc 3, followed by differential equations, followed by some program-specific course that uses all of that, right? That's a path of length 5 or 6. And if you're trying to follow that pathway and you don't pass any course on that pathway, you are by definition delayed, right? That pathway dictates the shortest amount of time it can take you to complete that program as well. It's not uncommon to find paths of length 10 or 12 in some curricula, right? That's what the delay factor is. It's the long pathways that you have in a curriculum. Blocking factor, the blocking factor is the number of courses that you can't take until you pass a given course, right? So you're blocked from progressing. You can't take that next course because you're blocked because you haven't passed the prerequisite course. Central courses are identified in this web app, and the central courses tend to be important. Courses with high centrality tend to be important to the discipline. And so a course with high centrality is a course where there are a lot of classes you have to take to get to it, and a lot of classes that open up in the curriculum once you pass it. That tends to be the high blocking factor tends to be a gateway course. High centrality tends to be the most important course in the curriculum. So it's a way of kind of finding those. And then the degrees of freedom, we don't have a way of formally doing that, but just something to think about, like how many different degree plans can you create from a curriculum? How many different ways can you arrange a curriculum? As you add more and more prerequisites, you start to limit your degrees of freedom. So here is an example of that. This is from the University of Kentucky EE program, right? 8 terms. And if you, I'm going to hover over calculus 1, which is down here. So here's calculus 1, and you'll see that it has a blocking factor of 15. So there's 15 green courses here. And you'll see some of these green courses are in the same term. That's because they're co-requisites. Okay. And then you'll see this blue pathway. That's the longest path from that course. And it has length 8. And what we did is we just did a regression analysis where we looked at graduation rates and those various metrics that I showed you. And we found that a linear combination of delay and blocking best correlates with graduation rate. It is the best way of quantifying complexity of a curricula if you want to relate it to the success of someone completing that curricula. So all that we've done here is for every course in the curriculum, we've added together the delay factor and the blocking factor, and we call that complexity. So this course has an overall complexity of 23. Then if you look at all of the courses in this term, they add up to having a complexity of 52. If we add up all of the complexity across all terms, they have a total complexity of 228. So that's how we come up with this complexity metric. It's fairly straightforward, but it is fairly informative. And 228 for an engineering program is, I would say, fairly normal. We'll see some that are at 600 and some that are a little bit lower. So that's what this is. Here's the most central course in this curriculum. Very interesting. In electrical engineering curriculum, take any one, plug it in here. We've done 60 because we did a study on this. Every single one has the same most central course. It's Circuits 1. Circuits 1 is the most foundational course in electrical engineering. Excuse me, it's the most central course in electrical engineering. It is the entry to the profession. And it is you've got to be able to get to that. You've got to be able to get to it soon in order for them to complete the rest of that curriculum. And so we're going to show you a study that was built around figuring out how to get people to that course more efficiently. So now I'm going to turn it over to Hayden. This is the Curricular Analytics website. And I would encourage you all to go to it now. And he's going to kind of walk you through the features of this website, create an account. If something breaks while you're doing that, we've got the guy, he'll debug it in real time for you, I think, perhaps. Hayden, are you there?
Yes, I think there was a hand raised. Bethany, maybe? I don't know if you had a question.
Go ahead.
No, I was trying to figure out how to raise my hand earlier when you were asking the question about whether we'd used it before.
Oh, I'm so sorry. Yeah, it's hard. It's hard. One day we're going to be together.
Archie Holmes has a
I
question.
do actually have a question, Greg, and it comes back to this complexity number. So if I were to look at a non-STEM degree, have you done that and seen? I mean, I'm just trying to get a sense of what this complexity number would look like outside of engineering or outside of STEM. Just a kind of level set, if you will.
I think you're muted, Greg.
You talk.
You're muted still, Greg.
There, sorry. That's my first mute error today. Thank you, Archie, and it's good to see you. So yes, the non-STEM tend to be far less complex. And it's interesting because I've seen some schools that look at the complexity where there's almost no complexity in the curriculum, and they ask the question, okay, it doesn't seem that we're building. It's like, what you should be building learning outcomes, right? And so I've seen it used in that other way. But yeah, low score on the complexity side is in the low 100s. And I've seen one as high as 700. But you're right that the non-STEM tend to be less complex. We did in the APLU study, it was interesting because we did it by discipline. And some disciplines have really varied, so surprising things like music education had a lot of variability and complexity, and then psychology almost none. So it does tell you that it seems that at least in those schools, people have a pretty set curriculum for psychology.
And
Kind of
as a follow-up question to that, Greg, does every curriculum that you've looked at have this central course?
That's a good question. I would say that some of those that have very low complexity, they don't have as strongly central of a course. This tends to be, if you have curricula that tend to build, a math oriented curricula where you've got to get these learning outcomes to get to something, it's going to show up more strongly in that. That's a really good question, Archie.
Okay, thanks.
Yeah.
Okay, so the first thing that I'm going to kind of touch on, Greg mentioned a little bit earlier, is kind of a refactoring of the hierarchy that you can store the curricula and degree plans in. So in the new version of the app, we built this notion of an organization, and for most purposes, the top level organization ends up being representative of a university. And that organization can contain any number of child organizations, which most frequently end up being the colleges in the university. And those child organizations can also have any number of child organizations of their own. So that might be the departments in the colleges. And then a curriculum, which has many degree plans, can belong to any organization. So it can belong at the university level, it can belong at the college level, or it can belong at the department level. And any of the, if you have a curriculum at the department level, then you're able to see that at the university level. And I'll show that in the app in just a moment. Okay. So this is the homepage of the app. If you're able to successfully get to it at curricularanalytics.org. I'm going to do a quick walkthrough of, sorry about that, of most of the major features on the app. And if at any point there are questions, or if there's time at the end and we want to maybe look in more detail at anything, please feel free to just raise your hand or say something in the chat. So this is the index page. The first thing we're going to look at is the sign up, which is up in the top right. And if you click that, then it's a pretty standard sign up form. You just give your name, email address, and a password. Once you've signed up, if you navigate to the login, which is right next to it, you just give the email and password you just provided, and you should be able to log in. And you should get a little message at the top that you signed in successfully, and you'll be redirected to the curriculums index. So this has a list of all of the curricula on the website that are either publicly available, so the person that uploaded it chose to make it public, or you uploaded it yourself, or it's been shared with you. I'm going to come back to this. The first thing I'm going to cover is the organizations, which we just touched on a minute ago. So if you navigate to the organizations page, which is just in the little nav bar there in the dashboard, you'll see a list of all the organizations that you either are a member of, have created, or own. So every user by default has an organization created for them that is their email address. And then for the demo, I created a University of Kentucky. So if we go to the University of Kentucky, I've set up one. You can see there's a list of child organizations. So I've set up one, which is the College of Engineering. And then there's a list of all the curricula in that organization. So there's an accounting curriculum and a computer science curriculum. If we navigate to the College of Engineering, then in that list, you only see computer science. The accounting program won't show up anymore because it belongs to the university, but not to the College of Engineering. But computer science does belong to the College of Engineering. So if we wanted to say, make a department of computer science or just, any new organization, to do that, you go back to the organization's index and there's a new organization button. If you hit that, you can type in a name, and you can optionally upload curricula files here if you want to upload a bunch, or set child organizations if you already have them defined. So for this, I just create Department of Computer Science. And then if we go back to the College of Engineering and we hit the Edit Organization button, then on this page, there's a prompt again to add a child organization. So if you hit that, and that'll bring up a select element. And so from that drop-down list, just selected the Department of Computer Science and scroll down and hit save. And you'll get a message that the organization was successfully updated.
Hayden, real quick, is anyone trying to follow along and create these organizations? Okay.
Yeah, if anyone's trying to follow along, I can slow down a little bit. Sorry.
Just real quick check, and I apologize. I didn't. Archie asked some questions, but I should have left time for if there are any other questions about anything we've done so far. So, so try to create your initial organization, and then you can create sub-organizations.
Yeah, and I'll wait a minute to give everyone a chance to do that and catch up if anyone's following.
Can you create the sub-organization again?
Yeah, sure. So to do that, it's not the most intuitive kind of flow. We want to change this. So what you'll do, if you already have the higher level organization, so the College of Engineering is already created, you just go back to the main organizations page and hit the new organization button. Give it any name you want, and then save it. And then if you go back to the College of Engineering, there's an option to edit. And if you hit that edit button, then there's a prompt here to add the child organization, which we select the one we just created.
Maybe you're going to get to this, but how do you have multiple people? How do you control, like if an organization's already there, how do you say, oh, now this person can go in and add child organizations to it?
Yeah, so this is something, I didn't include it in the main set of images here just for time constraints, but I can show it at the end if we have the time. There's a little sharing button right here. If you hit that, I can actually show it really quick if we want.
Yeah, I think that's a good
You have an
idea.
option to hit the organization's curricula or degree plans. Here, let me. Here we go. So if you have like an organization, like if I want to share, you have an option to select if you want to share an organization, a curriculum, or a degree plan. If you share the organization, then everything that's in it will get shared too. And the curriculum, if you share that, then all of its plans. But if you just share a plan, then it's just that one plan. So it kind of gives you like a more granular level of control. So if I go here to the University of Kentucky, you have 3 options. You can set someone to an owner, an admin, or just viewing. So an owner can edit the organization and things in it, and they also can delete it. An admin can just edit, they can't delete it, and then someone that can view just views. And so as it is right now, you have a list of all the users that you can then select. And if you hit save, then it shares it with them.
So it's a highlighted, as they get highlighted
Yeah.
on this list. I was confused. I thought everybody can view and admin everything. No, that's all users.
Yeah, so it's just hot. Yeah, exactly. So if I click this person's name, Orhan, then now he would be able to view.
And when you return, that will retain the highlighting.
Yep.
Got it.
So I'll go ahead and share that with Orhan. Oh.
May I ask really quickly? In fact, I was working with Chad yesterday about this, or not earlier this week. That doesn't seem to work for me. Like I have the UNL's entire organization created, and I couldn't share it. It didn't work. I hit submit and nothing was happening.
Okay. Yeah, this is something I'll make a note of this now to check into. I just had an issue with this the other day. Another user had a problem. They accidentally locked themselves out. So maybe when I fix that, there might be a new error.
I did that as well. I lost my entire other organization that I had entered on the original website. I made my new one, and my original one with all the curricular, I don't have access to anymore. I sent an email to support for this question. Anyway, I have to leave, but I will follow up on getting that information. Thanks.
Okay, yeah, absolutely.
Hayden, while you're writing, I'll slowly ask my question.
Sure, go ahead.
So it looked like just by creating an account, I created the equivalent of an organization that had my email name. So if we're going to have, say, one UCI organization, but I'm going to have other users access it, okay, then they can sort of ignore that organization that gets defaulted when they log in. I would just share the UCI organization with them, and then they would work on that. That way we don't end up like with two versions of UCI and things like that. That would be the mode by which we would use it, right?
Yep, absolutely. So
Okay.
the email address organization is just so everyone has their own little space. If you maybe want to play with some curricular or degree plans, but you don't want it to be listed as part of your university's catalog, or to be representative of anything. So it's just like a private space where you can upload.
So should I, if I'm doing it, I shouldn't make the organization that showed up when I logged in UCI. I should click on new organization button and make one for UCI as a total new organization.
Yep. Yes.
Got it.
And real quick, Patricia, we've got almost certainly the data's there. So work with us and we'll try to make sure that we make it visible to you again.
Oh, no, I hadn't panicked. I'm sure it's there. I just couldn't access it. So no worries. I just want to get it. So I've already got messages coming in, private messages. Hey, add me to UNL. And I need to do that, but we'll get it. Everybody else can get it,
Yeah. So early next week, I can, if you've already sent us an email, I'll get back in touch with you to find, and this is for anyone else that's had any problems like with their old data. It's definitely still there, and we can get you access again. And I'll have a fix for the sharing that since it's not working, so that you can share it with any of your other colleagues.
I have a question for the community here. So Hayden and I have been going round and round about this, trying to figure out, so I could log on and create an organization and call it University of California, Irvine. We could work to certify that, like, so for example, only one person is allowed to be called that, and we would contact the university to make sure, or just let someone do it. I mean, we're trying to figure out what's the right way to do this. Any thoughts from anyone? In the old version, you could just, people make their curricula publicly available. So, we do a lot of studies where we just go to a website, download it, and load it up and then analyze it. But with this one, someone could create, you could have multiple people having the same name. Well, you can't have the same name, but you could have multiple people trying to use the same name for university.
Greg,
suggestions, contact me.
Well, my quick, immediate thought is at this early stage, it would probably be useful to have the ability to certify one, but I wouldn't necessarily automatically prevent others, just because you don't know who's making mistakes or playing with it and doing it for real in some sense. Like, sort of like Twitter does, right? Like, it doesn't prevent you from creating an account, but if you meet certain criteria, you get the little blue star next to it. So that if it was easy to do and didn't add a huge workload for you all, you could certify certain ones as having been confirmed to be created by someone sort of high enough at the university food chain, whatever that would be.
Okay, that's a good.
Just so if, like you said, if people are coming and using this as research tools, they know which curricular have been uploaded by an official quote person versus someone taking it off a web and using it, and you don't know if the web's out of date or whatever.
Okay, it's a good suggestion.
Yeah, thank you for that, Michael. Yeah, and I think as we've been developing the site, we've been trying to find kind of the perfect middle ground between user control and so that they can manage what's uploaded to their university, at least the name attached with their university, but at the same time, keeping things public and open so that people can compare and look at one another. So. Okay. So I think if everyone is caught up at this point, we created the child organization for the College of Engineering and put it underneath as the Department of Computer Science. And so now if we want to move that computer science curriculum into the Department of Computer Science, there's an edit button next to the curriculum. And if you hit that, then you have an option here to select the organization that it belongs to. And that just opens a drop down. So if you do that, change it to Department of Computer Science and hit save, then your curriculum will move. And I believe, sorry, but yeah, so now if you go to the University of Kentucky level, you'll still see the computer science curriculum, and you still see it at the College of Engineering. It just basically allows you to filter and build that hierarchy. So unless anyone has any questions or issues, I'm gonna start to walk through the curriculum side of things. So creating a curriculum. Okay, so this is the curriculum index. Like I said, all of the curricula here are either public or you created them or they've been shared with you. So the first thing I'm gonna do is walk through creating a new one. If you hit the new curriculum button, this is what you'll be brought to. It's a pretty simple form. You just need to give the curriculum a name and an organization that it belongs to. And then you have two ways to upload it. You can upload it or enter it through our new slick graphical user interface that Greg mentioned, newly deployed as of earlier this week. Or alternatively, you can do it as a CSV file. So if you have used the Curricular Analytics Toolbox and read in any curricula or degree plans, it's the same format that the Toolbox uses. So you could just upload those onto the website and you don't have to change anything. But if you want to use the CSV file and you haven't before, there is extensive documentation on the file format, as well as some example files that you can download and then edit and fill in. And those are available at curricularanalytics.org/files. You can also find that if you hit the help button. It's linked on that page, which I'll show at the end. But for the demo, I'm going to walk through how to use the editing interface. If you do that, you just provide a zip code here, and then let me move my, the first thing you'll do is add a term. Now, even though a curriculum doesn't really have terms like Greg outlined before, but visually for the sake of putting this thing together, it's a lot easier if we kind of keep the idea of a term. If you add a term, then a space will pop up for you to add an item, which is your first course. If you hit that, then you're able to enter a name and the credits associated with the course. And you'll also notice that the curricular complexity and the credit hours have now appeared. And as you enter courses and requisite relationships, those will continue to update. So if you hit the finished button, the little check mark, that'll save that course. And I'm going to add another term. And then in that, add two more courses. So I've added an MA 113 and a BW 102. To add a requisite, you just click on a course that already exists. So if we click BW 102, there are two options down here to add a prerequisite or a co-requisite. If you hit prerequisite, then this little dialog here will change, and it says to click one of the highlighted items to make it a prerequisite. And you also have the option to cancel if you don't want to add it. So if you hover over BW 101 and then click it, it's now saved as a prereq, and you have the option to remove that by clicking the little garbage icon there. And you can save that again by hitting finished. And then I go ahead and add a few more courses and with a few more requisites. And you can see that the complexity, blocking factor, delay, credit hours have all continued to update. And you also have a legend down here. So the orange, the dotted orange, the dashed orange line shows the courses that are blocked by the courses that you're hovering over. And the dashed blue line shows the longest path that the course sits on. And then dark red courses are immediate prerequisites. Light red courses are a prerequisite of a direct prerequisite. So MA 113 has the prerequisite of BW 101. So it's an indirect prerequisite for MA 114. And then the same is true for courses in dark green and light green, and courses in yellow are co-requisites.
Real quick point I just thought about here, Hayden. A common mistake is people add a co-requisite. Let's say you have a chemistry with a chemistry lab that's a strict co-requisite. It has to be taken in the same term. You just put one arrow from the lab to the course. If you put another arrow coming back in the other direction from the course to the lab, you end up with a cycle, which is not something that you can have in these graphs. And so I don't know if this tool if the editing tool, Hayden, I've never checked that.
I believe it will prevent you from doing that. It should prevent you from adding any requisites that aren't allowed. So you won't be able to add a prerequisite. You know, for instance, I couldn't edit MA 114 to have BW 203 as a prerequisite since it's ahead of it. You can only do prerequisites for courses that are behind, and you can only do strict co-requisites for courses that are in this same term together.
Probably the most common problem that people contact us about is I can't get this to visualize, and then when we look at it, it turns out that it's a strict co-rec between two courses pointing in both directions. So just put one in.
Yeah. And I'll give a few seconds here for anyone to catch up if you're playing with the visualization and want to try to actually make a curriculum. But at this point, you're basically done. You can add as many courses and requisites as you want. And then when you're finished, you just hit the save button. And so once you've saved the curriculum, you'll get redirected back to the index. And you can see now that basket weaving is in the list. So if you click it out of the list, you'll see that the courses are not arranged exactly like they were here. BW 103 has actually moved from what looks like the third term to the first term. And again, that's because the terms in the curriculum don't really apply. It's just a visual element to help you put it together. So to keep the arrangement consistent, you would build a degree plan, which I'm going to walk through next. Once the curriculum is saved, you still have the option to edit it. So if you toggle on that editing button, you can make any of the same changes that you made when you were initially creating the curriculum. And to save those, you just hit the Save Changes button there, and you'll get a little message that tells you whether or not your changes were saved successfully. And if you scroll down to the bottom of the page here, every curriculum has at the bottom a list of all the degree plans associated with it. So for this curriculum, since it's brand new, there aren't any plans for it yet. But you also have the option to add new degree plans for the curriculum. So if we hit that new degree plan button, then it redirects you to a similar form as the new curriculum form. You have the option to use the GUI or the CSV file. For the plans in particular, we really recommend using the GUI, even if you use the file for the curriculum, just because the plan, as you can see, has automatically filled itself in with all the courses from the curriculum. So to build the plan, all you have to do is click an item and drag it to the appropriate term. And I'll actually show that. So if we go to the basket weaving curriculum and we select its degree plan, and we toggle on editing, you just click and you actually, so MA 114, since it has a prerequisite in the term before it, you're not able, you actually can't move this course at all. It has a strict co-requisite and a prerequisite. So it's locked into place here. But if you wanted to move, let's see, BA 103, then you just drag it and you can put it into any term you want and then save those changes. So I put for this demo, I put the basket weaving 103 back into the third term, like when we initially put the curriculum together, and it'll stay there now. And similar to the curriculum, you just hit save, you'll be redirected, and now you can see it in the list and visit it. And you have the option to toggle editing on and off and to save those changes. On the degree plan pages, you have a link to the curriculum that the plan belongs to, as well as a link to the organization that the plan belongs to. And you'll get the complexity and the credit hours, which, like Greg mentioned previously, the complexity won't change from the curriculum to the degree plan. Unless with the plans, there is the added feature that you can add additional courses to the plan. So since curricula and degree plans it's a one-to-many relationship. If you have a standard four-year plan for computer science, but then you also have a second plan that's pretty common for students that maybe transfer in from community college, or perhaps they need, they're not Calc 1 ready, so they'd have to take one additional math course. You can add that additional course to the plan and save it, and it won't change the curriculum. So you can add and remove courses to the plan, and it'll leave the curriculum as it is. And then the final thing, there's a help button up at the top of the nav bar that contains a lot of this information, as well as an email address. If you run into any issues like with sharing or accessing data that you uploaded previously, and the file formats and example format or example file are also all available on this page, in addition to like some frequently asked questions.
Any questions? Thank you, Hayden. It's awesome. Any feedback that you have on usability is welcome. So please feel free to provide feedback, and we gladly accept it.
Yeah, I see a couple of questions in the chat. So I see Beth asked, how do we enter requirements when there are choices among a set of courses? So I'm thinking that means something like a core course where you might have a lot of classes that could fill that. And Greg, do you want to speak to that?
Sure. So generally the way that we do that is you list it as a core course, and so for example, or upper division elective, it could be any set of courses, you just list it as that. And if you think that there is a requirement from some other course, you can add it. It tends to, this is where there's a little bit of inexactness in this, right? But I tend to just lump them together as one course and put them in the curriculum. I showed you the degree plans application that we have also created. That degree plans application can support the notion you're bringing up. Who was it brought it up, Beth? Yeah, that can support that notion, and we are working on having the ability to have those degree plans that are stored in that app analyzed in the curricular analytics toolbox. But what we would do, even in that case, is we'd take that requirement, which is a set of courses, and we would just make it a super course essentially. And
Great, thank you. Thanks, that's helpful.
And Paul had a question as well. How would you visually display a class that could be taken in parallel, but could also be taken after a class? And he gave the example that calculus-based physics might be taken in the same term as Calc 1, but it could also be taken after Calc 1 is completed. And that's a really good question.
We define that, yeah, we define that as a correct, not a strict correct.
Yeah.
So, and when, oh, go ahead, Hayden, sorry.
Yeah, sorry. I'll show you an example of that. So in the app, I have here basket weaving 101 is defined as a strict co-requisite for this Calc 1 class. So they can't be moved or separated. They have to be in the same term. But if I remove that and I add it as just a normal co-requisite, that means that they can be taken at the same time or after. So I could move MA 113 to the next term.
And our degree plan optimization algorithms take that into account when they try to find optimal curricula. They know whether or not they can be placed together or not. So that's our definition. We define strict as meaning you must take them together, and then co-requisite is it's either a co or a pre. Good question. So I think, Paul, I don't know if that answered your question, but from a curricular complexity perspective, if it's in one term or another, doesn't matter. It's not going to change the complexity. It changes the degree plan. And so we can analyze that, and we would just analyze both of them. Does that answer your question? Okay. All right. Any questions so far? All right, I think, is it back to me, Hayden? Thank you again.
Back to you, Greg.
Okay, let me see. All right, we're going to go over some studies, and Sue, I put some of these together, I think, just to try to specifically get to some of the questions that you were asking. And so let me kind of give a quick overview, and this is a subset of kind of the studies that we've done. We started this work at University of New Mexico, and we did some pretty simple stuff there. I'll show you the net impact. APLU did an interesting study. If you go to this URL that's right here, it is a little report that probably Steve and his team worked to put together on how they used it in their transformation cluster. Paper I recently read from Virginia Tech, they had a NSF Red project, which is redesigning departments. And there was a curricular redesign where they kind of did some work on some early courses. And they actually used that to show that it had a negative impact on transfer students because it was increasing the complexity of the transfer process. And so they you know, the way that the authors put this is they use this to quantitatively articulate concerns. And so they were able to bring that up with the department. And I don't know, Rachel might be able, I don't know if it were what ended up happening, but the paper mentioned the fact that they used this to try and look at what might happen to transfer students. At the University of South Florida, they did a campus-wide review as a part of a 3-campus consolidation where they were consolidating campuses and they needed to combine curricula. They needed to have one biology program across all of those campuses, and where previously they had 3. And so they tried to use this tool to help guide that conversation with a particular emphasis on STEM pathways. I'm going to show you this one because I thought that was quite interesting, some of the work that they did there. New Mexico State, I just found something online. They had a curricular analytics project where they kind of did a campus-wide review, and then they used this to look at both transfer articulation and complexity of plans across their institution. And then most recently, Hayden and I have been working with the Council on Post-Secondary Education to create a statewide transfer articulation system to automatically compute the 2+2 agreements rather than having to try and get people together to do them. There's some more combinatorics that you can check my math on, but if you think about a typical state that has, say, 15 institutions of higher education, and you want to move from one program at one institution to, say, transfer to one of 5 programs at a different institution, and you add up how many different combinations that involves statewide, right? It's an unmanageable number. Again, astronomically huge number, but it's something that you can compute. And so again, the ability to use these tools to actually figure out the best plan instead of trying to get people together to do it is what we're after with this. Let me start with the New Mexico one. I'll go very quickly. When I was there, we had this credit hour problem. We were accumulating too many credit hours. One of the problems we had is that we had a requirement of 128 credit hours for all of our degrees. And so we worked to get that lowered to 120. Could not even figure out why it was at 128. And once we did that, that's what led to the creation of these tools. We created these tools to say, let's study our curriculum and figure out if we can make them more efficient. And we were really just focused on credit hour reduction. And it's not just credit hour reduction that matters in curricular complexity, but that does reduce complexity. And so this was the starting point in 2013-14. We had everything was at 128. These different colors are colleges. So the orange was the College of Arts and Sciences. So you'll see there's 50 or 60 programs there. The red was the College of Engineering. This purple way out here, 139 credit hour program was education. They had a whole bunch of requirements for certification that once we talked to the state about, we got the state to relax some of them because they didn't realize that, they were beating us over the head saying, why don't you have, fewer credit hours in your degree programs? We said, well, you've got some requirements here for certification that are in conflict with the Gen Ed core. Can you harmonize them? And they did. So this was a useful tool for that. After 1 year, mainly arts and sciences reduced the number of credit hours in their program. In the next year, you'll see engineering got everything down to 120 and a few to 124. And it just continued. And I think it may have continued. There's not too many that are above 120 there now. And if you look at the total number of credit hours saved across the entire curriculum, we kept a running total. It was 664. What happened there is that inefficiency that I showed you in excess credit hours led to a low 4-year graduation rate. Reasonable 6-year graduation given the students that we served at that institution, but the 4-year was very low, 12.6, and it more than doubled over this 7-year time span. So that's a 300% increase in the 4-year graduation rate. Very little change in the 6-year graduation rate, which is quite interesting, right? So that really showed that it was an efficiency issue. The students really are trying to get out in 4 and just didn't have the pathway to do it. In terms of just tuition savings alone, this is not lost opportunity cost. It was at least $35 million a year that students were saved. So making those pathways more efficient was very important at the University of New Mexico. Now, here's one on math preparation that I think some of you may have seen before, but if you look, I've got a little annotation down here that shows if you go to our Curricular Analytics notebook site and want to actually see this study and run the code associated with it there, we've provided there. So you go to the CA notebook site and then the quality complexity studies is what this is. And we actually have published a couple of papers on this too. What happened at UNM is folks, primarily in engineering, said, okay, we've got highly complex programs because we're really good. And so this led to this question then of how are complexity and program quality related? And so we started with electrical engineering programs at doctoral institutions. We looked at US News and World Report rankings as a proxy for quality, which I think it is a pretty reasonable proxy for quality. And here's an example. I think Archie had mentioned that, this is a STEM that's got low complexity, only 118, right? There's the biggest blocking course is Calculus 1 in this curriculum, most central course, Circuits 1. Here's another institution, a huge number of courses blocked by Calculus 1, same central course, Circuits. And What we found was when we partitioned these schools according to their rankings, we found that the top tier schools, those schools that were in the top 20, tended to have much less complex curricula than those that were in the bottom 20. So the one school that I showed that was highly complex is from this collection of schools in the bottom tier of the ranking. Most recently, just this last year, Hayden and a group at University of Kentucky worked to do the same thing for computer science programs. And we found the same thing in computer science program, which is kind of interesting. In this case, we used the CS Org's ranking rather than US News and World Report, and kind of found the same phenomena exist there. So open questions to whether or not this continues to apply across other disciplines, but I think it's something that might be worth looking into. This Western study, they did some work in this area. Then we had a teaching and learning workshop that was a lot of fun at Colorado State University. And they shared, everyone kind of shared some of the work that they were doing, and I couldn't even begin to present all of it here. These were the schools that were involved in that. And as a starting point, they did these four. They ended up doing all of their curricula, putting them into the tool and trying to use that to guide discussions on their campuses about the impact that curriculum has on student success. And what I did is kind of look at particular curricula. So here's Colorado State. This is kind of just a dump of some of the things that you can get out of this tool. So I can figure out the blocking factor for all the courses, centrality, delay, complexity, but also these long paths. The long paths in the curriculum is something that the provost there really wanted Rick Miranda wanted folks to focus on. And the other thing is, they found a lot of variability in, say, animal science, but this is a question that Archie asked kind of previously. Not a whole lot of, very tight in complexity in psychology programs, a pretty big range here in mechanical engineering. So they used this data and kind of did their own thing on each of their departments, each of their colleges. But one of the things that I wrote down that that Rick Miranda at Colorado State told people is that he got the curricular complexity analysis for every program at the institution, and he got all of the deans together and he gave them 2 copies of each, and he asked them to take a look at the overall complexity score. Are there long chains, 6 or 7? Does your program have very few free electives? Are you delaying gen ed core into the junior, senior year? And can you take a look at these bottleneck courses? And they just did their kind of own study and let folks come to their own conclusion on things. I found that this tends to be the most effective way to engage with faculty, is to just provide them with the data and see what they can do with it, particularly if they see they're an outlier. And if they're an outlier relative to other similar programs at other schools too. They may want to explain why. I don't know, Rick, if you have anything to add to that, or Steve?
No, I think, this is Rick. I think that is what I tried to encourage the department chairs and the deans to look at. Trying to get them to do that during program review, especially at that moment in time. But really, they can do this at any time. And these 5 little metrics here to pay attention to, I think, were easy to enunciate, as you just did. And also, I think faculty members on the ground really get this. Every one of these bullet points, they live with year in and year out in their role as advising students. So they know that every one of these issues will have an effect on time to graduation and difficulty of getting a degree. So it's not a difficult conversation to convince them that complexity in these senses are problematic for student success. Going to the next step of actually gearing up to change the curriculum, this is hard. And I think that's when comparisons with other universities, curriculum can be compelling. I mean, faculty want to see data, right? They want to know, well, often they design curriculum based on what courses and what curriculum they took when they were in school, and it can easily generate a certain amount of groupthink inside of a faculty, especially a relatively small faculty. You have 15 people or so, only 5 on a curriculum committee in a department in any 1, 2 or 3 year period. So I think the ability to visualize and see some of these metrics for other programs that exist in what your department would consider peer institutions, very important in getting them off the dime to start thinking about revisions.
I couldn't ask for a better segue to what you just said, that, recognizing there might be an issue and actually doing something about it. And so that's this next one. It's some work that was done at South Florida, and they have a very, they have someone there who's working to get all of this data into the system. They're actually using the Toolbox, and we actually meet with her quite often to help her through and use this. And we actually presented right before COVID at their conference on this. We use the Wright State engineering reform as a part of this, but I want to share with you something that they did. They looked at 10 different degree programs, primarily in engineering, because they knew they had an issue there. And they analyzed subsequently, they've done all of their curricula, right? But they created the standard degree plan, but then they also looked at the different starting points that students actually used, and they analyzed the actual starting points and dramatic differences there. And then they met with 5 departments covering 8 different degree programs to review them. And they made quite a few changes there based on that as a part of that that consolidation we were talking about. And they actually had Hayden and I come down and talk specifically to engineering. And they ended up moving all of their engineering programs to 120 credit hour, which I'm proud of them. I think that's wonderful they did that. So here is their computer engineering program, which this is on the high end for complexity. This is the computer engineering program at South Florida, overall complexity of 430. But then what they did, and again, there's a course that's got a huge blocking factor of 30 here, right? Which is always calculus 1 in STEM in any engineering curriculum. In this case, it's computer organization. Here's something that I wanted to point out to you. The Toolbox has the ability to identify something that I call dead-end courses. This course is dead-end because it has a prefix that is not computer engineering, right? The computer engineering, I think, is CDA, and this is EEE, right? And I found, I did the same thing in the APLU, I searched through and found these dead-end courses. So again, a dead-end course, we call it dead-end if it's not in the discipline, but it doesn't lead to any other courses that follow it. So this is a materials course in a computer engineering program, right? Why are you taking materials in computer engineering? You might take that if you had a electronics course following it, but they don't have anything following this. So I would question, and they may have perfectly good reason for having it there, and maybe they use it in senior design, but why is that there? At another school, I found Calculus 2 in a biology program. And it was a dead-end course, nothing built on Calculus 2 in that program. And so, I was asking, well, why is that there? And they said, well, that's because Duke does it that way. That was the reason. So, which I don't think is a good reason. But, and then somebody else said, well, it's because it's required for MCAT. It turns out there is no calculus at all required for MCAT. So again, dead-end course. Maybe their students are advantaged by having that course, maybe not, but I think it's worthwhile recognizing that it's there. So there was a dead-end course in this curriculum. But if we add not math prepared, meaning that they're going to take college algebra and pre-calculus, the complexity jumps up to 563. And again, about 17 points means you're losing a point in 6-year grad rate. So these students, and we're now at 12 terms. Typical scholarships are going to end after 8 terms. So these tend to be students that are minoritized. They're coming to, they're disadvantaged coming to college to begin with because they didn't go to, not their own fault. They may have gone to a high school that didn't provide math. And I saw a report today that math in high schools is very much organized around socioeconomic status. And so there's some real inequity here. Then same thing, you can find the central courses and so forth. Here is the electrical engineering program, not very complex, right? Only 181. Same central course, most important course. But if you add the not prepared in math, this is not prepared in math or chemistry, actually, right? They've got to take both they assume students are coming ready to take a pretty advanced chemistry. If not, this jumps up to 351, more than doubles the complexity for those students who come to college a little less prepared. The pathway is just not there for them. It's highly complex. So here's computer science program, same 393. We add these math not prepared, not even a chemistry in this case, and we've got a overall complexity of 664. I thought this was a really important thing for them to do, to really make it known to faculty that if we are trying to serve these students, this may not be the best way to do that. So, a couple of things that happened after this. The computer engineering program became the only program in the state with the 120 credit hour curriculum, and I think subsequently all programs moved to that. This was as of a couple of months ago. I think Hayden, I think Keena told us that all of them have now moved. Many have restructured their prerequisites. So in order to reduce this overall structural complexity, and they were working with these other faculty, but what we did as a part of this study with them is we said, well, let's look at what Wright State did. Wright State saw this same problem. If you're not calc ready, then get yourself calc ready, and then come back and talk to us once you're calc ready, and we're just going to tag on additional semesters, right? And Nathan Klingbeil, the dean there at the time, said, might there be a better way? So here was that math program, right? And here's what happens if we added that, right? Again, we're at 361. This pattern that I'm going to show you shows up in literally every electrical engineering program. This Calc 1, Calc 2, take differential equations. Now you can take circuits, and now you can take circuits too. And the complexity of this overall pattern is 75 complexity points. If you add pre-calc, it's up to 98. College algebra, 126. Foundational math, you're up to 157. That's more complex than some engineering curricula as a whole. What Nathan Klingbeil did is he said, there's one learning outcome in circuits 1. You've got to be able to solve a second order linear differential equation. Fairly easy for me to teach you how to do that. If I can teach you how to do that, you can go ahead and take this and still take those math courses, but you can still get through circuits. And if I do that and put it in this Engineering 101 class, you can take Circuits 1 with your colleagues, right? You're still taking Calculus 1 and Calculus 2. In fact, this is better prep for that, right? And you're still going to take differential equations. You're not getting out of that, but I'm just giving you this one learning outcome. So one way to think about this is, and what I'm getting at here is what Rick mentioned. Actually, changing things is a different matter. Recognizing the problem is one thing. What happened here? They deconstructed the learning outcomes for the curriculum, and they put them back together differently. And this is something that Hayden and I are actually working to support in the Toolbox as well. We're working to create this notion that you could actually articulate the learning outcomes behind this, and we could try to automatically organize them in different ways and present them to you, or give you a way for you to visually explore them. They might lead to different courses. This led to the creation of a different course that had learning outcomes from other places moved to it and then reinforced later in the curriculum. What happens if you do this is significant. If you take that traditional pattern I showed you, just that traditional pattern of trying to get through calculus, starting from pre-calculus actually, and instead add this engineering 101 course that I showed you, you get about a 10% increase in student success, just simulating students moving through it with the same pass rates. But if you make that a high success rate course, that first engineering 101 course, almost everyone succeeds with that pattern. And so this is an example of just restructuring, not changing how you teach, but restructuring the curriculum can have a dramatic impact on student success outcomes. If we plug this pattern into this student coming to the University of South Florida, not math prepared, I've added this, this was right. So we were at 181 complexity, 351. If we add this engineering 101, which is right here as a prerequisite for calculus and also for circuits, you get this complexity down to 179. It's actually less complex than the original curriculum that they had. Now, the interesting thing that happened at Wright State is when they implemented this curriculum, people thought, well, there's two levels here, right? There's the curriculum for the students who come to us smart, right? And then there's this other one that's not so good. And it turned out that the reformed curriculum that started with Engineering 101 produced better engineers in the end. They assessed better in terms of their ABET outcomes. So it wasn't an inferior curriculum. It was actually a better way to learn. And it makes sense if you think about it. You present a concept, differential equations in this case, you give them the opportunity to use it in an engineering context, and then you reinforce it in a differential equations class. It's actually a better way to learn. And so this is an example of how you might use these tools. It takes a lot of creativity and so forth to do this type of work, but this pattern was applied, and they are talking with folks about doing that at South Florida. One more, Council on Post-Secondary Education. If you go to kydegreeplans.com, you'll see that we've got all of the degree plans for all of the schools in the state of Kentucky there, including all of the community colleges. There's 11 schools within this if you click on that. And so if you go to each of these schools, you can dig in, you can find out the degrees that they offer and the job opportunities associated with those degrees as well. And then you can do the same for the community college system. And, you can dig down in and see, the things that we would show you here is Northern Kentucky University, and this is the College of Arts and Sciences plan there. And so the first thing that we did, and it was a pretty heavy effort, was to just collect all the data for all the schools in the state. That sets us up to be able to do transfer articulation statewide. And this is what this overall process flow looks like. Students come to higher education with dual credit, community college credit, different university credit. I read a report recently that 35% of all students transfer at least once. And the average number of credit hours lost when transferring is 1 year. So this is in higher education. That's the study that was recently done by the National Center for Education Statistics. So there's a lot of loss in the transfer process. This ends up with some type of coalesced transcript for this student. It's got credits from different places. In the state of Kentucky, they have a database of course articulation for the schools in state. So we know that if you went to a community college, maybe more than one community college, we know how they're accepted by the other institutions in the state. And so we can apply this curricular analytics reasoning ability where we can reason over those degree plans. And this is something that I mentioned to you that we've recently developed to figure out exactly which requirements were satisfied at a given university, given this transcript. Okay, so from this, so what use cases does this provide? Well, now we can provide a portal at the state level where a student says, hey, I'm coming to Kentucky with this set of credits, and I want to find a biology program, and I want to search over all of the schools in the state, and I want to find the one that's going to give me the most credit. Or I want a report of how many credits I get in every biology program at every school in the state of Kentucky. This is something that we can do. So the student then may say, well, give me a plan at University B. And so we've got this degree plan optimizer that I'll explain to you briefly, where we can then map out the best plan for that student according to that student's constraints. That student may say, hey, I've got 45 credit hours. I want to finish in 3 years or 2 years, 2.5 years. Give me a plan that only involves 2.5 years at that institution and allows me to graduate. So that's what we can do with this new kind of workflow that we've created for the state of Kentucky, that we have as a prototype right now, but we're trying to kind of make this a battle-hardened application, right, where it can work kind of anywhere. So this piece, I want to talk a little bit about this. How do we create the right plan? Because this involves this optimizing a plan for a student, taking their prior credits into account, taking into account the fact that some courses are only offered in the fall or spring, taking into account that certain courses must be taken together, all of these types of things, right? And here's kind of my view of what we tend to do. We tend to provide a degree plan that works for this student, right? This student gets the degree plan, and it's the same degree plan we give to every student, right? Even though this person, this student is not starting in Calc 1, this student's bringing 31 credit hours. This student's got community college and an AS degree that she earned. This student is off plan and needs a restructured plan. In fact, my contention is that almost every student is off plan by the second year, right? There's some reason that they're not taking the exact plan that was handed to them on day one. It's very difficult for everyone to be on plan because everyone has credits they're bringing in. They are minoring in something, they're double majoring, right? And so you've got to be able to create an adjusted plan. Here's someone who's changed majors. They all deserve a personalized plan, and that's a difficult thing for an advisor to do. So what we wanted to do is create these personalized plans that satisfy certain nice properties that you can specify. And so you might even create some plans that are tailored for, hey, here's a plan that works well for students starting with this level of preparation in mathematics. Or something that we're looking at is this notion of toxic combinations of courses. Are there some courses that students should not take together? You know, we have found, for example, students with math ACT of 25 or less probably shouldn't be taking calculus and physics in the same term. I think Paul mentioned earlier this notion of you could take those courses together, but you could also push physics off one term. What we found that if you have a math ACT of 25 or less, you should do that. You should do that. Focus on getting through calculus then physics. I think we found at one institution, it was about a 10% improvement in a student's chances of successfully completing those courses if you separate them. And so the ability to kind of search for these toxic combinations and then separate them in a plan may have a large impact on certain student populations. So I'm going to skip through kind of some of this math, but basically what we did is we created an optimization algorithm where, and I'm going to use the mechanical engineering program at Colorado State University, somewhat complex, so it's hard to restructure this thing. But here's some degree plan analytics that we provide to this 4-year mechanical engineering, right? We can look at kind of the maximum number of credits in a term, the minimum number, and then you'd like to smooth that out. That's hard to do. If you've ever tried to do this, I've tried to do that in a highly complex curricula, and every time you move something, you mess up something else. Really difficult thing to do. And so I think that's why maybe they ended up there with 20 credit hours in one term and only 13 in another. But we can run an optimization algorithm, and that's the algorithm. I won't go through it, and it'll create a different plan. And that plan has one problem. It kind of spread some courses out that are prereqs, but it got things much better in terms of the balance. So this may be something that an advisor might be interested in using, particularly if a student's coming with prior credits. Well, if we want to fix that problem of trying to move those requisites closer together, we have another objective function that does that. And so now here's that same thing, but we reran it and said, keep things, keep Calc 2 close to Calc 1, please. Those types of things. It lost its balance. Oh, well, let's do them both together. So we've got the ability to do multi-objective optimization where we say, let's keep it balanced. Let's keep the courses that are prerequisites and postrequisites of one another as close together as we can get them. And we actually added a third thing, and let's separate toxic combinations. And when we do that, this is the toxic combination, we end up with this, where we're using those objectives. We've got things close together, we've got toxic courses separated, and we've got balanced curricula. So this is a capability that we are working to make available in the web app. It is available in the Toolbox at the moment, but you've got to be able to code. So this is something that we're going to try and provide where if you put in some constraints, like I just showed you, you could run them and get a different degree plan for a particular student's case and store it in the web app, curricular analytics web app. So with that, I think I left enough time for a few questions. If people are still awake.
We're awake, Greg.
Greg, I have a question. This is Rick Miranda from Colorado State. Seems like one of the fundamental capabilities of the software is from the point of view of both advising students and transfer evaluation is the following function. You have two inputs, one of which is the transcript of the student currently, what courses they've already taken. And the second is the curriculum they have to satisfy. And the output would be the degree plan going forward that would finish the curriculum given their existing courses that they've been successful at. So is that one of the fundamental functions of the toolbox to take those two components and output that here's the best advice for building out the rest of your time at the university here to get a degree?
Yes, that's exactly what that function does. So you can build in other constraints as well, like and this course is only offered in the fall, and you should take gen ed courses in this term, and you should take senior elective in these terms, and it'll try to satisfy all those constraints and spit out a plan. So I see that as something that an advisor would kind of probably use in an iterative fashion. That's what I found as I've used it. Like when we were trying to create a degree plan for that software engineering program I mentioned to you, we kept, oh, well, we don't want that course. So we'd add another constraint, but it kept, it would just pop out plans, and then we would, I think most advisors would say, oh, that's close enough. I just need to move this here, and then it's for me fixed.
If I may follow up on that, this is David Single from Montana State. I just want to ask the flexibility in the criteria used for the optimization. So does it include things like toxicity on the one hand, and on the other hand, limiting time to degree, especially for students on scholarships of limited duration?
Yeah, so one of the constraints is the maximum number of terms that you would allow. And so, it's possible, by the way, and I've done this, where you put all these constraints in and it says, it's not feasible. I can't solve it. It won't work. But yes, that is a typical so someone comes to you with prior credits and wants to finish in 3 years, you can easily construct a plan that does that.
Perfect, perfect. And I just wanted to make one other comment, and this follows up on something that Rick said earlier, and that is how do we go about creating these curricula? And it may be we create them on the basis of what we had done, but there's something about the structure that we create curricula for students who never miss a beat, who start at the original plan, starting point of the academic plan, never drop a course, never change major. In other words, we create curricula for the students that we do not have, rather than for the students that we do have. And so I love this idea of the application that allows these various pathways to be worked out, starting at different math points. And the other thing that that we're interested in, someday when the pandemic allows us to get back to work, is looking at path complexity associated with changing majors.
Yes.
So some of our curricula are over differentiated in the first year, over specialized. And as a result, if students decide to change major after that first year, they have essentially wasted a year of money. I mean, it's not a total waste. I believe they learn from the courses, but their time to degree is unnecessarily extended because of the obstacle that we put in their place by that over differentiation rather than emphasis on core in the first. And so looking not just along specific curricular paths, but the actual paths traversed by students in this is a real plus, I think. Thanks. It's really nice to see the developments.
David, one comment that I've learned, you mentioned we have, we create plans for students that they can't necessarily follow, that we don't have. We also create schedules that are based on those plans that students aren't following. If you look at the input that Ad Astra uses, they take those plans and they feed them in, and that's how they create the schedule for the next term. So what they're interested in doing is saying, well, let's have the real plans that students are following, and maybe we can create a better set of courses.
Greg, I'm thinking about your Parisian slide again, and the idea of, oh, let's take the knowledge of the courses that students want to take and offer those courses rather than the ones the faculty want to teach, and be prepared to collect spears.
So Greg and Dave, this it's actually worse than what you're describing, David. It's not that we create curriculum for the ideal student instead of for the actual student. We create curriculum for the ideal faculty member too. We create curriculum based on what the faculty member want to teach, rather than what the students need to learn. So we have to factor that into our thinking about
of course,
how to organize curriculum change.
We do that to avoid becoming pincushions.
I think there's some really interesting research that can be done by starting to look at underlying learning outcomes and associating them with the complexity of how you and when you attain learning outcomes. And one of the things I'd like to do with Steve's help and the Reinvention Collaborative is start to look at some of the underlying equity issues associated with some of the things that you all just brought up. Who is getting off track, and is the impact equitable? And I think, and also these toxic courses, who do they impact? And as well as the same program at different institutions, there's this saying that a minority student should go to the highest rated school they get into, right? They're more likely to succeed at that school. Well, is that because they're going to confront less complex curricula at the higher rated school? That's what our data shows so far. So I think there's an equity aspect to that I think is worth looking into.
The equity is the focus for the Western Land Grant cluster as well. So I think all across the country, you see people wanting to tackle entrenched forms of discrimination. I mentioned in the chat, we'll have a town hall Monday with Michael Denon and Richard Aram from University of California, Irvine. They're going to address that just in an hour discussion. They're doing a lot of data-driven reform work at UCI. But you know, everywhere you look, people are wanting to find a way to you know, reform restructure might be the better term here, their institutions in order to make them more equitable and fair to students. And I just think this tool, Greg, you and Hayden and all your colleagues and lots of other, you know, that you've noted who've worked on this, really is one great way to tackle it. And it has sort of the quality that it opens up conversation at the unit level among faculty who have the authority and the responsibility to make such a difference for their students. And if they just had the data, they had these useful visualizations and other tools, then they're inspired to kind of get on doing the work that they want to do. You're helping them do what they want to do, and we need them to do.
Well, thank you, Steve. And I want to give a kudos. There's a first generation student on the call who I think is going to graduate in 4 years. And I think it has been helpful for him to have a map that he's been following along with the whole time. So we'll all join you, Hayden, at graduation virtually, I hope, and at the end of this year. Yeah, how about applause for Hayden Free? I mean, how many presentations did you make when you were an undergrad to national leaders in higher education? You know, I made 0, as I confessed. We're enjoying doing this work and happy to collaborate with anyone. So, Steve, thank you for organizing this. Yeah, and thank you, Greg, and thank you, Hayden, and all the folks who've joined us this afternoon, or whichever hour it is in your time zone. We know your time is precious. We thank you. As I mentioned in the chat, we'll notify everyone when the recording is available and the slide deck is available. And we encourage you to share it and to you know, send questions along, because this is an evolving project that depends on everyone's input and you know, your ideas. And so they're very welcome, and you know, we look forward to them. So with that, I want to wish everyone a great weekend when it rolls around for you, and good luck in concluding your semesters. Thanks so much. Bye now.